This video will go through some examples and explanation of simple interest from the recursion and financial mathematics topic of VCE General Maths. And so a quick reminder, simple interest is an application of linear growth. Linear growth is the style of sequence where we are seeing each successive term being found by adding on a constant value. And so our recurrence relation is of this style where we have our initial value and we're saying that Vn plus 1, so the next term, is equal to the current term, Vn, plus this constant amount of d. So for example, we might have the sequence 1, 6, 11, 16, and each time we are seeing that we have this addition by a constant amount of 5. So if we were to convert this into or represent this as a recurrence relation, we'd have V0, so our initial value of 1, and our rule, Vn plus 1, is the current term plus 5, our constant value d. So when we start looking at simple interest as an application of linear growth, we're seeing the scenario where a loan or an investment is working under this constant increase. So we don't see these very often in real life, and we don't see them come up very much in our actual assessments in general maths, but they are presumed knowledge, this concept. So it's a good one just to run through. So a reminder again, we have our our recurrence relation format. And in this case, often the initial value or the starting point is called the principal. So it's good to understand that when we're referring to principal, we're talking about the starting point of the loan or investment. D is often given as a rate, so a rate of interest, that we first need to use that rate to calculate this constant value of D. Sometimes that rate might be given as a per annum interest rate, but then it is calculated over different time periods throughout the year. So perhaps calculated monthly or calculated quarterly. And what that means is then our rule represents that same time period. So if we're calculating the interest monthly, then our rule would represent the number of months in time that has passed. So we do not see this very often at all in simple interest, but it does exist within the scope of what we can be asked to do. So it's good just to make note of that. Moving into some examples now. Example 1, Sasha deposits $7,000 into a savings account with a simple interest rate of 3.2% per annum. First, we want to write down a recurrence relation in terms of S0, Sn plus 1 and Sn that can be used to model the annual growth of this investment. So first thing we want to take note of is the information that we've been given as part of the question. So here we have the initial value, S0, and we have the rate of interest. So first step is going to be, off to the side here, is to calculate our value of D. So to do that, our initial value, 7,000, times our rate, 3.2, divided by 100, and that gives us our constant addition of $224. We now put that together in our rule. So S0 is 7,000, Sn plus 1, with the current Sn, plus 224. In part B, we're now asked to calculate the total interest that Sasha has earned after 3 years. We have two ways of doing this. We can either apply 3 iterations of our recurrence relation, so find S1, then S2, then S3. Find the value of the investment after that time. So if we were to do that, S1 would be 7,224. S2, adding on 224 again, so 7,448. S3, $7,672. And so the difference, S3, compared to our starting value of S0, is an additional $672. So that's one way of using the recurrence relation to find out the total interest that has been earned. So note, it's not the balance of the account, it's just how much it's grown by. But another way of doing this, and many of you will remember, that we have a simple interest formula. And our simple interest formula is interest equals the principal, or our starting value, times the rate of interest times time. So how many time periods have passed? Over 100. So we can do the same thing here, the same calculation. We can find that our interest is equal to 7,000 times 3.2 over 3 years, all divided by 100, and we get the same outcome of $672 in interest. The third way of doing this would simply be to say, well, I'm adding $224 every year for 3 years, so I could just multiply that value of D. And that again will get you here. So there's more often than not multiple ways to arrive at the same point. In our second example, we have Ty borrowing $6,500, and it's borrowed at a simple interest rate of 4.5% per annum. Best thing we want to do is write a rule for the value of the loan Tn after n years. The thing to note here, we're being asked to write a rule, not a recurrence relation. So that means we're writing a general rule. Before we can do that, we still need to know what is our constant value of D. So D, again, will be our starting value. So 6,500 multiplied by our rate, 4.5 over 100. And so our constant value there is $292.50. Our general rule form will be Tn is equal to T0 plus D times N. So for this scenario, that means Tn is equal to 6,500 plus 292.50 times N. Ty intends to terminate the loan before it reaches a balance of $8,000. How many years will Ty be able to keep this loan? So here we want to know how long, so we need to find N, given that the balance cannot go over $8,000. So we set that as our value, and we can use our general rule from part A to solve for N. We're going to say $8,000 is equal to 6,500 plus 292.50 times N, and we get a value of N equals 5.12. Now I would use solve on my calculator to find that value of N. And now we have a decision to make. We need to check the context of the question to decide, well, we're not going to have a loan for 5.12 years. We can either have it for 5 or for 6. As Ty's loan is increasing in value, or the balance is increasing because we're talking about growth, at 5 years it will be less than $8,000. At 6 years it will be more than $8,000. So the scenario we want here is when it's less than, because it cannot exceed that value. So therefore, Ty can keep this loan for 5 years. Our final example, we have a sum of money invested into an account paying simple interest at a rate of 8% per annum. The total interest earned on this investment over 6 years is $27,000. We want to find the sum of money initially invested. So we want to find what was our initial value. We've got a time frame, we've got an amount of interest, and we've got an interest rate. So in this case, we can utilise our simple interest formula. So our interest equals initial times our rate times the time period over 100. We have all pieces except for the initial value. So we can say our interest, $27,000, is equal to V0 times 8% times 6 years over 100. And we can solve for V0. When we do that, we get V0 is equal to $56,250. So our initial value, $56,250. It is possible to build a general rule or to simply divide our interest earned by 6 years and work our way backwards from there. But again, it's about using the information that you do have in a smart way and knowing that you do have this simple interest formula. Just because it's not something we use often in this level of general maths doesn't mean you can't utilise it. Okay, that pre-existing knowledge is still there and you can still call on it whenever you need to. That's it for our recap of simple interest. Hope that helped.